Hello, everyone. Welcome to this econometric course. This is a course on foundation of modern econometrics using a unified approach. My name is Yongmiao Hong. Welcome. So this is the first lecture in which I would like to introduce what is econometrics and then discuss some the concrete examples that show how econometrics theory, method, and tool could be used in economic research. And at the end, I'm going to discuss the requirement of this course, the grade policy, and also show you textbooks, both Chinese and English, as well as the course websites. And for this course, this is the table of the content that we are going to discuss, right? So today we have finished chapter 1, which is the introduction to econometrics, right? And then chapter 2 is going to be a general regression analysis that is going to be viewed from probability perspective, right? So we are going to discuss from probability perspective, what is the nature of regression analysis? Here, there's no data. We don't involve any data in chapter 2, right? So this is going to be a general regression analysis viewed from probabilities perspective. It's going to highlight the nature of regression analysis. Especially the nature of linear regression model and what is going to be called the correct model specification, right, for conditional mean. And then chapter 3 is going to be discussion on the classical linear regression model. The classical regression model, there are some key assumptions there, right? So we are going to start with those key assumptions. And then we then discuss ordinary square estimation, discuss goodness of fit, and also model selection criteria, and then discuss the probability property of ordinary square, consistency, efficiency, sampling distribution of ordinary square, and variant covariant metric estimation, and so on. And then hypothesis and application, right? And finally, when there exists conditional heteroscedasticity and autocorrelation in regression disturbance, we have to use generalized least square estimation. Generalized least square estimation will further provide insight into linear regression model. So, chapter 3 is about classical linear regression model. And this is used as a starting point for us to develop modern econometric theory. So my strategy here is going to relax the classical assumption in linear regression model sequentially, and then develop economic theory, right, based on more general assumption. So for example, we are going to relax conditional homoscedasticity assumption, right? We are going to relax serial correlation assumption. We are going to relax exogeneity condition, right? So allow endogeneity. And then we are going to extend linear model into nonlinear model. And nonlinear model will include movement conditions so that GMM theory are going to be developed. And then we are going to consider likelihood model, probability model. And probability model could be correctly specified, could be misspecified. So that is going to generate the QMLE and also Corsi MLE methodology. So the course is actually different chapters are closely related, right? Chapter 2 is a foundation for regression analysis. it is a preparation for chapter 3. And chapter 3 is just going to provide the basic idea, basic theory from classical point of view, right? So that is why we call it a classical regression model. So from that one, then we extend to chapter 4. So this is going to be, chapter 4 is going to be a linear regression model. Chapter 4 is a linear regression model where conditional homoscedasticity is going to be relaxed. So you could see that what happened to ordinary square estimator, consistency, normality, efficiency, if they exist conditional heteroscedasticity, right? So that is going to be a deviation from chapter 3. And chapter 5 extend regression model into time series regression. So you could see here, this is time series regression model with dependent observation. And it is going to be time series linear regression model. We are going to introduce basic concept in time series, like stationarity condition that I impose, right? And we are going to introduce some other like ergodicity, like autocovariance, correlation, and so on, right? So martingale different sequence, IID, and so on. Those basic concepts are going to be introduced here. And then after that, we are going to consider time series linear regression model. So this is an extension of classical linear regression model into time series content, right? And then chapter 6, again, is time series linear regression model. But now the regression determinants may display conditional heteroscedasticity in autocorrelation. In other words, that epsilon I may be correlated, like autocorrelated. Earlier, from chapter 4, chapter 5, and also chapter 3, we assume that epsilon I is uncorrelated. So there exists no serial correlation in regression determinants. But chapter 6, we allow not only they exist conditional heteroscedasticity in epsilon I, but they also exist autocorrelation in epsilon I. And of course, the motivation why we need to consider this general case, right? And what are going to be the difference? Especially, we need to estimate a so-called long-run variant covariance metric. Right? These are all going to be discussed in chapter 6. In chapter 7, we will relax the exogeneity condition. What is meant by exogeneity condition? Exogeneity condition means that the expectation, right? So the expectation of epsilon I given xi is equal to 0. That is the so-called exogeneity condition. Put it simple. If there exists only one way causality, but not the other way, right? So there exists no simultaneous equation bias, then exogeneity condition will satisfy, right? But that assumption now is going to be abandoned. We are going to allow two-way causality. More generally, we are going to allow endogeneity. And if we allow endogeneity, then we need to use the so-called instrumental variable regression methodology. And chapter 7 is considered a linear regression model that suffers from endogeneity. So we are going to use the so-called two-stage least square, and we are going to explain what is meant by two-stage least square and develop the theory, including the consistency, normality, efficiency, and also hypothesis test, right? Chapter 8 is going to extend linear regression model into a nonlinear model. And the nonlinear model is going to be characterized by a movement condition. The movement condition itself could be generated from a econometric model, or it could be simply generated by economic theory. The general estimation methodology here is going to be GMM. It's going to be generalized method of movement. Generalized method of movement is closely related to the classical method of movement estimation in statistics, right? But it is invented by econometricians. And we are going to develop the theory of GMM, and then also discuss using GMM to estimate and to test economic hypothesis. Chapter 9, again, is going to be about nonlinear model. But now the nonlinear model is not characterized by a movement condition. It is going to be characterized by a conditional distribution. And the conditional distribution could be correctly specified or could be misspecified. And that is why this chapter is called MLE and QMLE, maximum likelihood estimation and Cauchy maximum likelihood estimation, right? So now, as you could see the course material develop, we start from regression. Regression is just conditional mean. And then we are going to extend it into linear regression model, from linear regression model into nonlinear regression model, from nonlinear regression model to nonlinear movement model, from nonlinear movement model to nonlinear likelihood or nonlinear probability model. So the course material is developed in a sequential manner, right? But the methodology we use to organize the material actually are the same. We have been using law of large number central limit theorem, right? And using the Taylor expansion, using the conventional or popular asymptotic tool. So although each chapter covers a different topic, but we are actually using the same analytic tool. And by going through step by step, chapter by chapter, at the end, you are going to get a good command of the asymptotic tool that we use in this course. So that is one important feature. That is, the chapter actually are logically related to each other, right? And we use chapter 2, chapter 3 as a starting point. Especially from chapter 3, we are going to relax the classical assumption and then develop modern economic theory based on more general assumptions, right? And then the analytic tool that we use, including law of large number central limit theorem, right, Taylor expansion, that has been repeatedly used in every chapter. So by doing this, we are able to get a good command on how to apply them to do econometric theoretical analysis, right? And another important feature that is emphasized in this course is that as the course material that I just go through, right? The outline that we just went through, they are pretty quantitative. They are pretty mathematical oriented, right? But in each chapter, we actually provide economic motivating example, telling you that the econometric model considered in each chapter actually are going to be motivated from economic perspective. So we provide motivating example from economics, right? And we also discuss possible application in economics, that those methodology, econometric model, methodology and tool, where they could be applied in economics, right? We also provide economic intuition, economic explanation for the econometric model, for econometric method, and also for econometric tool. So intuition and economic motivation, economic explanation, this so-called economic training, economic thinking. This is also an important training in this course. So we are not going to train you how to do analytic work in developing economic theory, how to do asymptotic analysis in econometric theory. We also train you how to think econometric model from economic perspective, right? And that is an important part, right, indispensable part of the econometric training. Finally, in chapter 10, this is going to be a general summary, right? So this chapter is going to summarize what we have covered in previous chapter and what are the important features. And it also displays certain prospects, right? What are likely to be future development in modern econometry, right? So this chapter actually is quite integrated chapter. It summarizes all the material, all the econometric theory, method, and tool that we developed in this chapter, and discuss their link, their differences. In addition, we also point out some possible future development in modern econometry. So those are all the course material that we are going to cover in this course. This course, the grading policy is that there are going to be homework, right? Regularly assigned homework that are going to be 20%. There are also going to be a midterm exam, 40%, right? And finally, a final exam that is also 40%. So these are the course grading policy, right? In the textbook, there's a Chinese textbook called Advanced Econometrics. This is published by China Higher Education Press in 2011. This is in Chinese. There's going to be also an English textbook. This is called Foundation of Modern Econometrics, a Unified Approach. This is forthcoming in World Scientific Publisher, right? And the two books actually cover more or less the same material, although you see a different title here, right? And the lecture are imposed online, right? And these are in course website, right? So there's a course website here called 1Course163.com that has the English the online lecture. There's also the online lecture are also posted in a Chinese website, right? And that is it is called AE, Advanced Econometrics, right? So these are the website information. So this is a general introduction to the course, to econometrics, and also provide information about textbook, course website information, and the requirement for the course, right? Especially the grading policy.